Hello and welcome to another one of D's ADD videos. Today we're going to be looking at examples of the quotient rule. Quick recap. Um, Anytime we have a function that's got a top and a bottom, or the high and the low, you do low d high minus high d low, or low squared. That's the bottom minus times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. If you prefer u's and v's, where v's a bottom and use the top, here's the formula there. G's and F's, if that's what you're into, whatever makes you happy, whatever floats your boat. So let's look at this example here. So this is going to be the top up here and the bottom, so it's going to be the bottom. Alright, let's just do the formula again. Low d high, that means bottom times the derivative of the top minus high d low. It's always the second one that's being derived. You always start from the bottom to work your way up and then back down. If that makes sense. So let's apply it. We're going to have the bottom, which is 4 plus x cubed, times the derivative of the top, which is 2x plus 2, minus the top, which is x squared plus 2x plus 1, times the derivative of the bottom, which is 3x squared. Alright, and that's all over the bottom squared. Now, unfortunately, I created this problem to where nothing really simplifies or factors out, so you're just going to have to brute force it. If you do some FOIL action, you're going to get 8x plus 8 plus, what is that, 2x to the 4th plus 2x cubed, minus, and then distribute this 3x squared through, so it would be a minus 3x to the 4th, minus 6x cubed minus 3x. And then I'm just going to keep working with this top. Just keep in mind that this is still on the bottom. Here we have an x cubed. Here's an x to the 4th and x to the 4th, right here and here. So combining those, we're going to get a negative x to the 4th. And then we have x cubed term here and here. Combining those, we're going to get a negative 4x cubed. And then what do we have? We have a x squared. No, we have an x and an x here. So that would give me, I'm sorry, I got distracted by my dogs, a 5x, oops, 5x, and then the only thing left is that plus 8. Let me write it over that denominator. Okay, that would be your first example that we went through. Let's look at this one here. If I do this one here, we have low, which is 4x squared plus 1 cubed, d high, which is 4 times 5x cubed minus 1 cubed, and then we multiply by the derivative of the inside, 15x squared, and then minus high d low. Again, rewrite the inside without changing it first, then multiply by the derivative of the inside, and all that's over the bottom squared. Alright, so what we are going to do is, just like in the product rule example, we're going to factor out the greatest common terms and hopefully make our lives easier without having the screen jump around too much. Okay, so I see that there is a 4x squared cubed here and a 4x squared, or 4x squared plus 1 squared. So the lowest one of those I can pull out would be a 4x squared plus 1 squared. Numerically, there is a 4 common to the 8. And x-wise, we do have an x squared and an x. So I should have factored out 4x in front of that. Let's move to the left a little bit. Alright, a 4x there. And then, actually, there's a 15 and a 3, right? So there's a 3 that's common to both of those as well. So let's change that 4 to a 12. Alright, we're trying to simplify our work once we pull all this stuff out. And then there's a 5x cubed minus 1 to the third power is the smallest of both of those. And then you take hat over factor to figure out what's left. So I had all this wonderful goodness right here that I'm circling around with this little gray circle. And I'm dividing by all this I factored out. So the 4x, or let's do the numbers first. So the 4 cancels because of the 12, leaving me a 3. And then when I do that, I have a 5 left. Or in other words, if I had a 60 divided by 12, it does give me a 5, hat over factor. And that 60 is the 4 times a 15. So I write down a 5 left over. And then the 4x squared plus 1 cubed, and I took out a squared, so I'm left with one of those 4x squared plus 1s to the first power. And then 5x cubed minus 1 cubed, I took all of those out, so none of those are left. And then I only took out an x, not x squared, so I need to do the x right there, squeeze that in. Alright? And that's what's left. That's a lot cleaner, a lot easier to deal with. And then here on the second group, I'm going to have one of those 5x cubed minus 1s left over. And then the 3 is gone, the 4 is gone. I've got a 2 left. Squeeze that in right there. That's a 2, I promise you. And then the x is gone. So what about the 4x squared plus 1 squared? That's also gone, right? So that's all I have. You see how that simplified to a lot neater an expression? If we were finding critical points, for instance, you could just set that numerator equal to 0 now. 1 power raised to another power, this 3 squared, you multiply the powers. And then you can do a little canceling, right? Because there's 2 of them up here, and there's 6 of them down here, so there'd be 4 left. And then you want to distribute what's inside the brackets and parentheses. Let me separate that. So if I do that, I'm left with a 12x times 5x cubed minus 1 cubed. It seems like the algebra is taking more time than the calculus, huh? So if you don't have a good solid foundation in your algebra, go back and review. It's never too late. You don't want to have cracks in your foundation, especially cracks that big, because algebra is foundational to pretty much all of the mathematical sciences. It's like not knowing your alphabet or how to interact mathematically. Alright, so that's that multiplied out. Let's double check. Never hurts, right, to double check. Better to err on the side of caution if to err at all. It's a fancy way of saying better safe than sorry. So here we combine your like terms. We got 10x cubed plus 5x plus 2. And then those other guys or girls, I'm not sure I would think I'm sexist in any way. And there's your answer. Oops, that was the last part I did. There's your answer, sorry. Alright. So first plug into the general formula. After you do that, then factor out what you can, and then cancel if you can cancel. Alright, so practice, practice, practice. Thank you and have a nice day.